Hi, hello. Hi, hello, good evening. This is Maruti Prashad. Yes. Hi, hi, hello. Welcome to Unacademy YouTube channel, all of you.
Prashad, yes.
This is Maruti Prashad Satluru. Yes, welcome to Unacademy YouTube channel, all of you. Thank you, thanks for coming. Yes, this is Maruti Prashad. Yes, I have more than 13 years of experience in teaching chemistry for EAMCET, JEE and NEET students. Yeah. Hi, all of you. Very good evening. Welcome to Unacademy YouTube channel. Thank you. Hi, Jhansi. Very good evening. Welcome, Jhansi. Welcome to Unacademy YouTube channel. It is. Hi. Please subscribe this channel. Don't forget it, and please like it as well as share it if you really like my session. Okay. Don't forget to like it as well as share it, and don't forget to subscribe it also. Please subscribe this channel and please like it as well as share it. Okay. Right. Today I'm going to discuss. Yeah, fine, Jhansi. Fine. What about you? I'm fine. What about you, Jhansi? Yes. Yeah. Today I'm going to discuss about the solutions chapter. Solutions. In which I'm going to discuss only the methods of concentration. Methods of concentration of the solutions only I'm going to discuss right now. Okay. So it is very important to all the hi Harika. Hi Harika. Hi HS Technicals. Very good evening. Welcome to Unacademy YouTube channel, all of you. Thank you. Thanks for coming. So if you have any blur, please increase your resolution at minimum 360 pixels. Right. So you know very well, solutions chapter is very important with respect to IPE. It's a board examination. In board examination, solutions chapter is very important to you. And today I'm going to discuss about only the methods of concentration. Only methods of concentrations of the solutions. Suppose if I give one solution to you, like sugar solution or salt solution or any other solution like HCl or NaOH or some other solutions. If I give some solution to you, if you want to know the concentration of a particular solution, how can you calculate the concentration of a solution? Just simply by seeing that particular glass or particular beaker, you cannot calculate the concentration of a solution, right? But if you want to calculate the concentration of a solution, you have to choose some important methods. Yeah, hi Mahesh. Hello, very good evening. Welcome to Unacademy YouTube channel. Thank you. Thanks for coming. You have to choose some methods of concentration of the solutions. Okay. So that methods of concentration of the solutions we need to discuss right now. It's only just a half an hour concept. It's only a half an hour. Yeah. Hi Ramu. Good evening. Hi Ramu, very good evening. Welcome to Unacademy YouTube channel. Thank you. Thanks for coming. So there are so many number of methods of concentrations we have. Let us discuss one by one. Okay. Yeah. The first and foremost. Hi Jaya, good evening. Very good evening, Jaya. Welcome to Unacademy YouTube channel. Thank you, Jaya. Thanks for coming. So the first and foremost important methods of concentration is weight percentage. This is very important methods of concentration. Weight percentage, or simply we can say that it is W by W percentage. So if you want to calculate the concentration of a given solution, suppose if I give one solution to you, if you want to know the concentration of that particular solution, like I'm giving a sugar solution, just now I have given the examples also. If I gave a sugar solution or salt solution or HCl or NaCl or NaOH, whatever it may be the solution, you have a solution but you don't know the concentration. You don't know the concentration of a solution. So to calculate, to know or to measure the concentration of a solution, you have these important, you should know these important methods of concentration. The first one is weight percentage. and the second one is volume percentage. Second one is volume percentage, that is V by V percent. You can write like this. Yeah. Hi Bhanamurthy, very good evening. Welcome Bhanamurthy, welcome. If you have any doubt, please ask me without getting any hesitation. And the next one is weight volume percentage. There are three main important: weight and volume percentage. Okay, these three are the most important methods of concentrations of a given solution. Okay, apart from these three, some more important methods of concentrations also you have to know. They are all most important for us. They are all most important for us. This is weight percentage, W by W percentage, volume percentage, V by V, and weight volume. If you know the weight as well as volume, simply you can calculate the methods of concentration, like the concentration of a solution with the help of weight volume percentage. Okay, and after that, molarity. Molarity is also one of the important concentration method. Okay, yeah. Yeah, no, 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 Jhansi, today there is no hybridization class today. Tomorrow, from tomorrow onwards, we will start regularly. From tomorrow onwards, we will start the classes regularly. Okay. Molarity as well as normality. Molarity and normality and molality is also one of the important methods of concentration of a given solution. Okay. Molality. And the next one is mole fraction. Next one is mole fraction, molality and mole fraction. These seven are the important methods of concentration of a given solution. Of course, in sometimes we can say that this ppm is also one of the important methods of concentration. Anyone, can you give the definition or the abbreviation for ppm? Anyone? There are so many of learners are there here. So many viewers are there here. Anyone, can you give the abbreviation for this ppm? What is meant by ppm? Anyone? Please tell me. If you know, please tell me what is ppm. Anybody? Simply, it's a concentration term. It's a term of concentration. ppm. What is meant by ppm? You can measure the hardness of water in terms of ppms only. So there is a concentration of the hardness of given water sample. Okay, anybody is there? Very good, Shivkumar, very nice. ppm means it is parts per million. Very good, it is a parts per million. Very good, Shivkumar, good. ppm means parts per million. So these 8 are the important methods of concentration to calculate the concentration of a given solution. That's all. Is it clear? Let us discuss one by one. Of course, weight percentage, volume percentage, and weight volume percentage is different. Now we are going to discuss about the molarity first. Molarity. Okay. Yeah. See here. What is meant by molarity? And how can you calculate the concentration of a solution by using this molarity concept? What is meant by molarity? I am writing only a small formula for the calculating of molarity. That is this: molarity capital M is equal to N by V. Molarity capital M is equal to small n by capital V, where small n is equal to, it is the number of moles of solute. What is this solute? You know very well, if you take any solution, it is the combination of two words. Solution means it is the combination of two components. Solution can be combined with two components, that is solute as well as solvent. How many of you know this concept? Solution equals to solute plus solvent. How many of you know? I think almost all you know this concept of the combination of solute and solvent will give the solution. Is it right or not? Please tell me, anyone. Do you know about this concept or not? Solution means it is the combination of solute and solvent. Yeah, anyway, no problem. Yeah, solute and solvent. Solute means it is less quantity. Solute means it is less quantity, whereas solvent means it is high quantity. So high quantity substance, high quantity component is called as solvent, whereas less quantity of component is called as solute. Okay. See where n equals to, here the n means if you want to calculate the concentration of a given solution with the help of molarity, n equals to molarity capital M is equal to n by V. N by V. Small n means it is number of moles of solute and V means it is volume of the solution in liters. Volume of the solution in liters. Yeah, you know Ravati, very good, nice. Super, super Ravati, very good. So N means it is number of moles of solute and V means it is volume of the solution in liters. Okay? Yes. Good, good. If you take a sugar solution, what is solute in this? Sugar solution low, what is the solute in this case? You can easily say that. You can easily say that given answer. You can easily say that particular question. In sugar solution, what is solute and what is solvent? Please tell me anyone. Yes, very good. Satvik. Hi, hi Sivakumar. Very good evening. Welcome Sivakumar. Welcome to Unacademy YouTube channel. Thank you. Very good, Satvik. Sugar is the solute, whereas water is the solvent. Okay. So if you want to write not in liters, if you want to write it in milliliters, good. Water is a solvent. Very nice. So 1 by 1000, 1 by 1000. Sorry, not 1 by 1000. It is, yeah. N by V into 1000. So if you want to convert the liters to milliliters, you have to multiply it with 1000. So molarity is equal to N by V into 1000. That's all. Or molarity is equal to N by V, whereas V is in liters. That's all. So this is the concept. How can you calculate the molarity of a given solution? Got it or not, all of you? All of you got it or not? I think I am clear. So molarity M is equal to N by V, whereas V is in liters. Very good. Or otherwise, molarity is equal to N by V into 1000, whereas V is in milliliters. That's all. These two are the important formulas to calculate the molarity. That's all. And see here. Yeah, good question. Very good question. What is the relation between molarity and normality? I have not yet discussed about the normality, of course, but there is a small relation between molarity and normality. That is, molarity capital M is equal to oh sorry, normality is equal to N into molarity into small n. Normality is equal to molarity into small n. Yes, Sivakumar, very good. Sivakumar, very good, very good. Okay, here what is n? N is equal to n into m. Capital N is equal to n into capital M. This is a different case. Manideep. Now n means normality, m means molarity. Small n means what? Small n means it is a factor. That means suppose if you take acid solution, for the acid n equals to basicity. Okay, if you take the base, for base n equals to acidity. If you take salt, for salt n equals to, it may be the number of electrons which are travels, or salt means it is the charge. Either it may be positive charge or it may be negative charge on the cation or anion. That's all. So N equals to N into M. Normality is equal to N into molarity. This is the relation between normality and molarity. Got it, Manideep, or not? Manideep, are you got it or not? Please tell me. So you know the two important formulas for molarity. Yes. Yeah. Please wait. Please wait. I am discussing one by one. One by one I am discussing. Because that is the concept in, yeah, because that is the concept in normality. That is the concept in normality. So if you want to calculate the acidity, you have to check for OH groups. That means the replaceable hydrogens. If you want to calculate the basicity, you have to check for OH groups. That is the calculation of acidity and basicity. But let us discuss one by one. Because we are discussing about only the molarity first. We are discussing only the molarity. So molarity is having one more important formula. Molarity is having one more important formula. I am going to discuss right now. Suppose if you dilute a particular solution, you know very well molarity is equal to N by V, or molarity is equal to N by V into 1000, right? This is in liters, whereas it is in milliliters. And what about N? N means it is the number of moles. Anyone please tell me, if you want to calculate the number of moles, what is the formula? If you want to calculate the number of moles, what is the formula? Number of moles, N is equal to W by GMW, where W equals to, what is W? It is weight of the solute only. Weight of the solute only. Very good. Very good. Good, Satvik. W by GMW. Perfect. What is GMW? It is gram molecular weight of solute only. Gram molecular weight of solute. The weight of solute, gram molecular weight of solute. Just substitute this formula into the above one. Just substitute this formula into the above one. Then you will get M is equal to W by GMW into 1 by V, whereas V is in liters. This is one of the important formula you will get once you substitute this N value into the M. Very good. Perfect. Or otherwise you can write like this: M is equal to W by GMW into 1000 by V, whereas V is in milliliters. If you have the volume in milliliters, you have to use this formula, and if you have the volume is in liters, you should use this formula. So these two formulas are very important for us to calculate the molarity of a given solution. Suppose I'm using one more important formula to calculate the molarity. Suppose if I add some quantity of water into the solution, what about the concentration of the solution? Anyone please tell me? Anyone please tell me, if I take one solution, I add so much quantity of water into it. What about the concentration of the given solution? If I add some quantity of water like solvent, what about the concentration of the solution? Anyone please tell me? Will it increases or decreases? If I add, yeah, good. There is no main Henry's law, Manideep, main Henry's law and Raoult's law, okay, as well as colligative properties, as well as solubility. Solubility means P naught minus P by P naught, like that. It means RLVP, like that. And these concentration terms. These four are the important topics. Henry's law మీద ఒక ప్రాబ్లం అడుగుతాడు, రౌల్ట్స్ లా మీద ఒక ప్రాబ్లం అడుగుతాడు, కాలిగేటివ్ ప్రాపర్టీస్ మీద ఒకటి ఉంటుంది, కాన్సంట్రేషన్ టర్మ్స్ మీద ఒక ప్రాబ్లం ఉంటుంది. If you know all these four important topics, definitely you will crack the solutions chapter. There is no doubt about it. Okay, right. So I am giving one more important formula to you. Good. Not increases, Manideep. It's very simple question. No, not increases. If you add a small quantity of water, the concentration of the solution decreases but not increases. How it will increases? If you add the solute, suppose if I am taking a sugar solution, I am adding a small quantity of water into it. If you add the water, the taste will be reduced. That means the concentration will be reduced. It will not increases. So the concentration will be decreases, but the number of moles will be equal. That is most important. So my important topic is my important intention is if if you dilute the solution, if you dilute the solution, what about the concentration? You dilute the what about the concentration? Concentration decreases, but the number of moles, what about the number of moles? The number of moles remains constant. The number of moles remains constant. The number of moles remains constant. This is most important concept to you with respect to molarity. So if you add some amount of water, if you add some quantity of water, the solution concentration will be decreases, but the number of moles of solute is remains constant. Number of moles of solute will remains constant. There is no change of number of moles at all. Okay, see here, what is the formula to calculate the number of moles? What is the formula to calculate the number of moles? N is equal to m into v. N is equal to m into v. So before dilution the molarity is m1. Before dilution the volume is v1. After dilution, after adding some quantity of water, the molarity is m2. After dilution the volume will be v2. Here the m1 v1 equals to n1, m2 v2 equals to n2. The number of moles are equal as per our concept. So the relation is m1 v1 is equal to m2 v2. m1 v1 equals to m2 v2. This m1 v1 equals to m2 v2 is called as, this is called as, very important it is, that is called as dilution law. It's called as dilution law. It's called as dilution law. So m1 v1 is equal to m2 v2 is a dilution law. That means suppose if you take some solution, and if you add some quantity of water, what will happen to the concentration? You know very well, the concentration will be decreases. There is no doubt. The concentration only will be decreases, but the number of moles of solute will remains constant. The number of moles of solute will remains constant. That's why I can write like m1 v1 is equal to m2 v2. This m1 v1 is equal to m2 v2 is called as dilution law. It's called as dilution law. I think I'm clear, right? Very good, Ravati Pati, correct. But you opted in late manner. Anyway, no problem. Yeah, right. Suppose if you want to calculate the molarity, but you don't have the number of moles. You don't have the moles. You don't have. Okay. If you don't have the number of moles ni దగ్గర లేవనుకోండి, then how can you calculate the molarity? Suppose if you have the weight volume percentage, if you have the weight volume percentage but you don't have the number of moles, how can you calculate the molarity? That is my question. This is very important question to you. This is very important formula also. Molarity is equal to 10 into W by V percentage, that means weight volume percentage, by GMW. Okay, if you use this formula you can calculate the molarity if you know the weight volume percentage. Suppose in the problem if they give weight volume percentage to you, how can you calculate the molarity? By using this formula you can calculate the molarity. M is equal to 10 into weight volume percentage by GMW. GMW you know very well, that is gram molecular weight. So if you use this formula you can calculate the molarity by using W by V percentage, that means weight volume percentage. నీ దగ్గర weight volume percentage ఉంటే you can easily calculate the molarity by using this formula. Okay, and in the same way, suppose if you want to calculate the molarity once you have the density of the solution, you have the density or specific gravity, if you have the density or specific gravity of a given solution, then how can you calculate the molarity? So I am giving one formula to you to calculate the molarity if you know these two parameters. M is equal to 10 into I opted 6 times. Decrease no change. లేట్గా వస్తుందన్న రేవతిపతి కొంచెం లేట్గా నాకు కనిపిస్తోంది. ఎనీవే గుడ్ వెరీ గుడ్. 10 into specific gravity, 10 into specific gravity into weight percentage whole by GMW, whole by GMW. This is the formula to calculate the molarity once you have the specific gravity. Once you have the specific gravity, this is the formula to calculate the molarity. In the same way, suppose if you have the density only but not the specific gravity, then 10 into density into weight percentages by GMW. This is also one of the important formula to calculate the molarity of a given solution. Once you know the hi Suresh. Hi Suresh, good evening. Welcome to Unacademy YouTube channel. Thanks for coming. So if you want to calculate the molarity by using density and specific gravity, you can calculate the molarity by using these two formulas. Okay, or otherwise if you have weight volume percentage, this is the formula. Okay, this is the dilution law. M1v1 is equal to M2v2 is the dilution law. Hi Manohar, very good evening Manohar. Thanks for coming. Yes, one more important formula. There are two important formulas we have again with respect to molarity. That is M equals to M1v1 plus M2v2 by V1 plus V2. At what time you are using this formula to calculate the molarity of a given solution? When we are using this formula? Yeah, Muhammad Sohail, hi, good evening. For multiple choice questions, so many number of books are available in the market. You can use the corporate textbooks, or you can use Arihant publications, or you can use Pradeep's chemistry, or you can use Deepthi series, or you can use what we call that's all. They are most important, but first of all you have to know the concepts. Okay, for MCQs, yeah, very good. So M1v1 plus M2v2 by V1 plus V2. When we are using this formula, suppose if you take a mixture of two solutions, if you take a mixture of two solutions of different molarities, okay, if you have two solutions but the molarities are different, if the molarities are different, then how can you calculate? I am adding one solution to other solution. Here the volume is different, molarity is different. Here the volume is different, molarity is different. Suppose it will forms a mixture. I want to calculate the resultant mixture molarity. I want to calculate the concentration of a resultant mixture. How can I guess, or how can I calculate? This is the formula. M is equal to M1v1 plus M2v2 by V1 plus V2. Yeah, hi Tanay Kumar, very good evening. Welcome to Unacademy YouTube channel, Tanay. Thanks for coming. And one more important formula also you need to use, that is M1v1 by N1 is equal to M2v2 by N2, where we are using this formula only in titrations. If you do the titration between the two different type of solutions, titration means it is a practical method. It is a volumetric analysis. In the volumetric analysis or in titration method, if you are titrating or if you are neutralizing two different type of concentrated solutions, then you have to use this formula to calculate the concentration of a other solution. Suppose if you know the concentration of one solution, and if you want to calculate the concentration of other solution, then if you have to use this formula, M1v1 by N1 is equal to M2v2 by N2. Hi Mahesh Kumar, very good evening Mahesh Kumar. Thanks for coming. Okay, M1v1 by N1 is equal to M2v2 by N2. That's all. This formula can be used only in titration method. So this formula can be used when we are mixing two different concentrated solutions. Okay, that's all. So this is up to this, our today's session will be completed. and in the next session we will complete the normality chapter. This is all about molarity concept. This is all about molarity. How can you calculate the molarity? How can you calculate the molarity? And what are the important formulas to calculate the molarity? What is the definition of molarity? Yeah, hi Sai Kumar, very good evening. Yes, Mohammed Sohail. Sir, previous year paper also very important. Yes, previous year questions are also very important to you. Please read carefully previous year questions. And in my special classes from March onwards, I will start the previous year questions. Okay. So please come to my special classes also, Mohammed Sohail. Thank you. Bye bye. Today's session is over. And in the next session, we will discuss or we will meet with another new topic. Another new topic. Until then, keep watching my videos. Thank you. Bye bye. Yeah, Sai Kumar. G. Sai Kumar. What I need to do? Sai Kumar, what I need to do? 2020 questions. Okay, definitely. Definitely, Sai Kumar. If the Unacademy is giving me more number of classes in March, definitely I will discuss the most important previous year questions also. Okay, right. Bye bye, all of you. Thank